I am Anil Kumar. Welcome to my series for middle school students. Now, this particular video is on scientific notation. We'll take up many examples with real life applications. And this video can be helpful for even senior school students. So, we'll talk about scientific notations and some applications. To begin with, a number can be written as a times 10 to the power of something. Now, when we write in this fashion and when we make a the coefficient of 10 to the power of n as a number between 1 and 10, where 1 is included but 10 is not included, that is to say that the number a should be greater than equal to 1 but less than 10. A single digit number before decimal. That's what we are trying to say. And after that, we multiply that by 10 to the power of n. And n can be any integer. It could be a positive number or it could be a negative number, right? 10 is the base, as you know. But this integer n has a special name. We call it order of magnitude, since it directly gives you how big or small the number is. And this number a in this particular case is called significand. This gives you the rounding or accuracy to the significant figures. So we'll look into that part also as an extension to this particular topic. So as you can see, the scientific notation which we are discussing here has a lot of meaning in it, right? So very big numbers or very small numbers can be written in a very concise way with a lot of meaning. Meaning is that if I write a number which is, let us say, 2.5 into 10 to the power of 6, then that number really means that it is to two significant figures, accurate to two significant figures, and from the magnitude can be taken out from this 10 to the power of 6. We know we're talking about something in millions, right? So in this case, it is 2.5 millions. You see that. So straight from the power, we know that this number is in millions. So we get an order of this, and that is why n here is called the order of magnitude, right? And that is the accuracy of the thing. Good. So these are two significant things which I thought I'll share with you about the scientific notation. Now let's look into it. Writing real numbers that are too large or too small in decimal form as a times 10 to the power of n, where absolute value of a is at least 1 but less than 10, and the exponent of 10 is an integer. Now here we have used the word absolute value of a, right? See this, we could also represent negative numbers. So I could definitely write minus 3.52 into 10 to the power of, let's say, 3, right? We could write this. In this case, the value of a is what? In this case, the a represents an integer, minus 3.52. So it could be a negative number also. So when we are defining it as between 1 and 10, we're actually restricting ourselves to the absolute value of a, correct? So that is how you have to look into it. So generally we just say that a is greater than or equal to 1 and less than 10. And if it is a negative number, we can always write a negative sign before it, right? So that is another way of looking into it. However, it's kind of important to understand all these differences. So I hope now it is absolutely clear. So as I was saying, the coefficient a is called the significand. It can have negative values. The exponent n is called the order of magnitude. It helps to compare numbers easily, right? Now with that, we have a question for you to explore. Which number is greater? 9.2305 times 10 to the power of 2 or 2.12 times 10 to the power of 5. So you have to write down which one is greater. So to find which one is greater, good option is to go for the n value, the exponent, which gives you the order of magnitude directly, right? So we can very clearly see 10 to the power of 5 is a much bigger number than 10 to the power of 2. It is 1000 times greater. You see that? So you can say this number is 1000 times greater. Which number? Which has a power of 10 to the power of 5, right? So that is how, comparing the index, you can easily find out which number is greater. If they have the same index, then of course you have to check the number, right? Okay. Now, before we get into the details of this particular topic, there are a few skills which should be known to you. So I'll take them in short. So I'd like you to pause this video at this stage, just look at the screen and see if you know all this, correct? If not, you may be required to learn these skills to move forward. Okay, so one thing is 10 to the power of 3 is actually 1000, 10 to the power of 4 is 10,000, and you know 10,000 is greater than 1000, so that sign makes sense, right? Basically, we are just comparing the exponents. Now here the exponent is 4, correct? So, which is greater. So comparing the exponent, you can figure it out. But if we have the negative exponents, then you also know that minus 3 is greater than minus 4. So 10 to the power of minus 3 is definitely greater than 10 to the power of minus 4, correct? Now, multiplying by tens, hundreds, thousands, or powers of 10 is another very important thing to consider. Now, in this particular case, 123.456 times 100, 10 to the power of 2 is 100. So we are expecting a bigger number. This decimal will move 2 points to the right, and therefore what you get is 12345.6. So whenever you multiply by 10 or its positive powers, the number increases and the decimal moves right. So you can clearly see here that the decimal moves right. But when you divide, what happens? It moves towards the left and makes the number smaller, as we have shown it here. Correct? Now, these are the properties of exponents. When you have the same base, you can add the exponents when you multiply, and you need to subtract the exponents when you divide. And therefore, 10 to the power of 5 times 10 to the power of 2 should be 10 to the power of 5 plus 2, right? So 5 plus 2 is 7. That is how you get it. When you divide, you have to take the difference, 5 minus 2, which is 3. So 10 to the power of 5 divided by 10 to the power of 2 will be 10 to the power of 3. Now, when you divide by any number, it is same as the reciprocal of multiplication, and that is what we are trying to say here. 4.6073 divided by 10 to the power of minus 2 is 4.6073 times 10 to the power of 2. So remember, when I say 10 to the power of minus 2, it really means what? It means 1 over 10 to the power of 2, which is 1 over 100. Does it make sense to you? Correct? So it means when you're dividing by this, it means multiply by its reciprocal. And the reciprocal is 10 square, right? So dividing by 100 is, dividing by 1 over 100 is multiplying by 100. And that is how you get your result. Very important thing to consider before moving forward. Now the next one here is what happens when you multiply by a negative exponent. So 10 to the power minus 2 basically is 1 over 10 to the power of 2, which is 1 over 100. So basically you divide by 100, moving the decimal left 2 places, you get the number. Is that clear to you? Right? Now here is a test example for you. You can just see if it makes sense. Okay, 0.001. If you are given 0.001 and if you have to convert that to the power of 10, what could you do? You could multiply both the numerator and denominator by 1000. So when you multiply 0.001 by 1000, you get 1. And in the denominator, you have 1000. So definitely, this is 1000th. So which is written as 10 to the power of minus 3. So 10 to the power of minus 3 is 1000. 10 to the power of minus 6 will be 1 millionth, right? Okay. So now we also have an exercise here to do. Try to figure out what is this number. 10 to the power of minus 2 times 10 to the power of minus 3 divided by 10 to the power of minus 5. So when you multiply, you actually add those exponents. So minus 2 plus minus 3 makes it minus 3. And then when you divide, you take away. So minus of minus 5 will be plus 5, and what you get is 10 to the power of 0. Remember, anything to the power of 0 is always 1, correct? So any number to the power of 0 is always equal to 1. Now these are very important things to remember, and you may refer to this page while doing some questions, and if you don't get a concept. Is that clear to you? Take it as a summary of your requirements. Now let's move forward and see some examples, right? So let us see some examples where we should be using scientific notations. They make more sense. So here in the table, we have some numbers. Observe the numbers written in the scientific notation. Explain how the exponent of 10 is related with the movement of decimals, right? That is kind of concept which we have to look into. So when I write a number 7, I could write this normal number 7 as 7 times 10 to the power of 0. Anything to the power of 0 is 1, so you get 7. Now, it is a scientific notation. You have A, which is 7 times 10 to the power of n is 0 in this case. Now, it is to be recommended here that 10 and exponent is omitted when the exponent is 0. So in scientific notation, I could also write this as just 7. So that really means times 10 to the power of 0. Really? So that is how it is, right? So when the power of 0 is there for 10, we normally drop it. Correct. Now, 365 days in a year, you could write them as 3.65, 300, right? 300 means 10 to the power of 2. And even otherwise, you can see you have to put a decimal after the first term. So there are two places where the decimal should move. Since the decimal is moving towards the left, we have to multiply, and that is the whole concept. Multiply by the number of positions shifted by the decimal. So the concept here is, in this case, we have to, if the decimal moves right, in this case, let's say decimal moves, let's start with left first. Okay, if the decimal moves left, in that case, what do we get? We get multiplied by 10 to the power of something which is positive. And if it is right, in that case, 10 to the power of something which is negative, right? That is as good as dividing. So negative powers means dividing. The next number here is 12,742. Now in this case, if there is a decimal here, 1, 2, 3, 4 positions you have to move left. Since you are moving 4 positions to the left, you should be multiplying by 10 to the power of 4, positive 4, correct? Now we have another number, 37 million, right? 37 million we have to write as 3.7 into 10 to the power of 7, right? Million is 10 to the power of 6, but we want to put a decimal after 3. So it is 3.7 to the power of 7. Now, these numbers which I have taken are very, very useful numbers. Now, 12,742 is actually the diameter of the Earth in kilometers, and 37 million is actually the population of Canada. And here we have a very small number, 0.000089, which is written as 8.9 times 10 to the power minus 5. Now this is the human hair diameter in meters, correct? So the diameter of your hair is around that much, right? Now, a nanometer is a unit which is now so popular. How much is it? It is 1 into 10 to the power of minus 9. So I thought I'll just include this since this is in fashion these days. Nanometer, 10 to the power of minus 9. So you have a trillion, which is 10 to the power of 9, and 1 over trillion is the nanometer in this case, which is written as shown here with, you see, the position of the decimal, 9 positions to the left, right? So that is what a nanometer is. Now we have a trillion here also, 37 trillion, which gives you the number of cells in the human body. So 37 trillion can be written as 3.7 into 10 raised to power 13. Okay, so that is the trillion. Okay, sorry, this was billion, okay, not trillion. So 1 over billion will be nanometer, nano, right? Okay, now based on this, here is an exercise for you, which is example 2. Numbers in scientific notation can have negative exponents of 10. Find the range of number with negative exponents. Range means when we have this number, what could be its value, absolute value? Tell me that. So what could be the range of number? If I have a number something like this, let us say we have a number a into 10 to the power of minus some number, and it could be any number n. Is that clear to you? In that case, this number, let's call this number as capital N, will be between what two numbers? This is a question for you to answer. So I'll leave it unanswered here. We can always come back to this. Write down as comments and then see if you really understood this question. Okay, so let's move on and take the next example. Example 2. We'll talk about the basic particle, the electrons, the protons, and the neutrons. They're too small, right? So we do need scientific notation to represent their mass, for example, or the orbit in which they move, or so many things related with them as a charge also. There's so many things, even their numbers in a particular volume, right? So all those numbers are actually always written in scientific notation for concise perspective. So the example here is mass of proton is given to you, right? Mass of proton, neutron and electron is given below to the nearest four significant figures. So when I say four significant figures, you can observe here these are four numbers written in scientific notation. 119. These are A values, right? Where that part of A is a number between 1 and 10, right? Greater than equal to 1, less than 10. So 1.673, 1.675, 9.109 are the real numbers, and their value is between 1 and 10 times 10 to the power of minus 27, minus 27, minus 31, all negative exponents. So that means that the mass is very, 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 very small, correct? Now 10 to the power minus 27. Remember, how many zeros are you going to place to get it, right? 27 extra zeros here will make this number, right? So before 1, do you see that? So that is how you're going to write this number. So this decimal will actually move 27 places from where it is at present. So writing that will be something which is very difficult to understand. But now in scientific notation, you can easily understand. Now the question for you is arrange them in ascending order by mass, right? So we are given the mass of these three basic particles, protons, neutrons, and electrons. Now you need to write them in the ascending order, means minimum increasing order, you can say, right? So ascending means increasing order. So you can always write it down. The answers also I have actually given here. Now you have to compare. Order means you have to compare with the exponent of 10. Now minus 37 is the lowest, correct? So that comes first, and then minus 27. We have two of them. We have to check which one is higher. Neutrons are higher, so they are heaviest of the three. So electron, proton, and neutron will become your answer as shown here. Does it make sense to you? That is how you are going to compare. Now remember, the coefficient A, the significand, provides direct indication of precision or the accuracy of this measurement, which is up to 4 significant figures as you can see here, right? And n is called the order of magnitude in A times 10 to the power of n. So while comparing the order, we could straight away compare the value of n and get our answer, right? Now, let's look into big things. Our planet. Well, nothing can be bigger than that. Okay, so what? Mass of some planets is given below. Arrange them in descending order. That means in decreasing order, right? So in this case, you have to arrange them in decreasing order. I'd like you to pause the video, understand all this, write down the answer, and then look into my suggestion. So we have only taken 4 planets, Earth, Mars, Mercury, and Jupiter, and provided their mass. Now tell me, how will you compare the masses? Well, you have to check the order, the exponent, correct? That is one thing. Now all are given to 4 significant figures in this case also, right? So now you can compare directly with the exponents. We have to write the decreasing order. That means the first position goes to which one? Well, 27 is the highest number, so that will be first. Jupiter, is the heaviest of all the planets. And now next, we are comparing these two. While comparing Earth and Venus, we see that the Earth is 5.9, so that is in the second position. Venus takes the third, and then fourth position goes to Mercury, where the index is 23. So simple comparison starting with the index n gives us the solution. Is that clear to you? Okay, now here is something for you to explore. The mass of Sun is also given to you, which is 1.989 into 10 raised to power 30. And around how many times is Sun heavier than Jupiter? That is what you have to compare. So I'd like you to pause the video and then compare this. That is going to be good exercise. So when you want to compare, you're basically dividing 1.989 into 10 to the power of 30 by the Jupiter, which is 1.898 into 10 to the power of 27. Think about these to be similar. So it could be like 30 minus 27, and which is 1000 times. So you can clearly do these type of exercise and figure out that 1.98 and 1.89 is very, very close. So more or less 1000 times. You can say, well, the Sun is 1000 times the mass of Jupiter. Perfect. Now, let's take more examples, interesting ones. Speed of light. Now, light travels, very, very fast. So, speed of light is 299,792,458 meters per second. That's the speed of light. So, you have to write this to three significant figures, right? Using scientific notation. Now, that is your exercise. You can now pause the video and round it to three significant figures. Well, 7. So, you're going to round at this particular point. What do you get? Well, when you round this, then you also know that we have to see decimal places. So decimal will move 3, 3, 6, and 2. 8 places, right? Let me write down this. 2, 9, 9, 7, 9, 2, 4, 5, 8. Now, in this case, we want to write this as a scientific notation. So here's the decimal. Moves 1, 2, 3, 4, 5, 6, 7, 8 position, right? So when you write this as 2.9979 whatever into 10 to the power of 8 will come. Since we need to round it to three significant figures, in that case 7 is greater than 4, and therefore this 9 will be increased, and so clearly you get 3.00 into 10 to the power of 8 as your answer. Perfect. So that is what the answer is, and that is how you're going to calculate the answer in meters per second. Correct? So that's a very convenient way of writing that whole big number, right? Now, let's also look into the speed of sound. Speed of sound is 343 meters per second. It's pretty fast, right? Faster than any train which you have. Well, we do have supersonic trains also now, but anyway, it's comparable to the fastest trains which we have. All right, so 343 meters per second, right? So that is the speed of sound. You can see the lag in the two speeds, and that also explains you why you see the light first and then you hear the thunder. Correct? So that is how they are very much connected. Let's round it to three significant figures and write it down. So when you have 343 and you want to round it, then in that case the decimal, which is assumed to be at the end, now moves to two places, and therefore this will be 3.43 into 10 to the power of 2. Since we moved it left, it has to be a positive power. The number is actually a bigger number, right? Okay, so that is how we get it. Now here is another explore question for you. It is state if the following statement is true or false. The statement for you is light travels 1 million times faster than the sound. Oh my God, is it true? How do we figure this out? You can pause the video and answer this question. Does light travel 1 million times faster than sound? Well, let's compare 10 to the power of 8 and 10 to the power of 2, right? That clearly says 10 to the power of 6. Yes, it does. And so this statement is correct. So such a easy calculation. Do you see that part? Right? So that makes things so simple. Right. Let's move forward and see how do we really write the scientific notation, right? Till now we have seen most of the examples related to our earth, right? And we've gone deep into every matter, looking into the electron, protons, and the neutrons. And so we have covered everything in between. Perfect. Now, how do we really write the scientific notation? That is a process which we need to understand. And we are going to understand with the help of a table. Let's take a number. In this case, I've taken speed of light. We are developing a scientific notation for large numbers in this particular case. So the speed of light is 2,997,92458 meters per second. How do we write this in scientific notation? That is the whole exercise. So what we will do here is we'll do one by one. So I could actually write this as something times 10, right? So what I did was that I brought a decimal place to 10th place and so multiplied by 10. It is the same number as before. Scientifically, we have to write this as the product of 10 to the power of something. Since I moved decimal one place to the left, I have to increase the power by 1 for 10. Do you see that? So every shift in the decimal to the right or left, so we say every left shift will add 10 to the power of n plus 1. So whatever was the power, you add 1 to that power, right? For a number normally, it is 0. So if you shift by one position, you add 1, it becomes 1 as we have written here. Now again, we moved it to now this time 2 points and so we get 10 to the power of 2. So in this process, you will develop a table as shown here. So keep on multiplying by tens until you reach this position when the number is between 1 and 10, right? Less than 10, greater than equal to 1. So we are looking for a place where the value of a is between 1, it could be equal to, but less than 10, right? So negative signs we're keeping separate. We're just talking about the absolute value of a, right? Remember this. So absolute value, right? Some of our grade 7 students may not understand absolute value, so we are not just putting it everywhere, right? Okay. Now, so the value magnitude of a should be less than 10 as soon as it and greater than 1. So at this stage we know it is greater than 1, right? And it is less than 10. Earlier it was greater than 10 also. So at this stage it has become less than 10. There we stop. So we have one position on the left of decimals and others on the right. And so we get that in the scientific notation. And that is what we call scientific notation. Perfect. That is how we do it. So I hope this process is absolutely clear. So in short, let me again remind you that when you move decimal to the left, exponent goes positive. Perfect. So that's the summary of our learning. And you can see all the figures in the form of multiplication by 10 and as powers of 10. So we have multiplied by the products of tens, right? So that is the powers. Now, let's take another example. In this case, I'm taking a very small number. So wavelength of visible light is between 0.0000004 meters to 0.0000007 meters. So this is the wavelength of light. So everything travels like light, they travel in a wave. When we say wavelength, we're trying to see how much is the distance between 2 points which are like kind of rising ray. This much distance is what we're looking into. Now for a light, it is that much. It's a very small wavelength, and that is why these lights can also penetrate the glasses because the glass particles are farther away than this particular distance. So they can actually penetrate through the glasses without breaking them and enter your house. That's the beauty. Perfect. So let's talk about this visible light. Visible light is always between two particular ranges. We say infrared and ultraviolet. So these are the two ranges which we are talking about, right? I'll not disclose which one is which because that is the part of your explore activity. Okay, so let's begin. So the wavelength is points, 0.0000007 to 0.0000004 to 7, right? Okay, so let's begin with the smaller number and see how we can write this into the scientific form. So we have to travel this particular distance. How do we do that? Well, in this case, you have to move the decimal to the right, correct? So in this case, we are moving decimal, which place? Right, correct? Decimal is going right, correct? So we have 10 to the power of some negative number n. Is that clear to you? So that is the basic to understand. By how many positions? So we can count here. Let's count it here. It's better. 3 and 3, 6 and one more, which is 7. So we have moved it right to 7 positions, right? So in this case, we have moved it right to 7 positions. So it should be 10 to the power of minus 7. That's a short way of doing it. But what you're doing here is showing the whole process. So what you do here is when you move it by one place, right? We move it to one place. In a way, we divide by 10. That's how you moved it, right? So that's what we do. So you could write this as 0.00 instead of 6 zeros, 5 zeros this time, times 10 to the power minus 1. So minus 1 is like divide by 10. Effectively, you still have 6 zeros before 4. Does make sense to you, right? It's kind of same thing. So I'd like you to grasp this activity and see how you can actually depict conversion to scientific notation. That is extremely important exercise. Now, the question for you here is explore 5. Wavelength of infrared light is more than the wavelength of the light as ultraviolet light. So infrared is more. So and ultraviolet is smaller. In now from the given figures, estimate the wavelength of infrared light if it is one extreme of the visible range. So wavelength of infrared is more. So we have to basically figure out which one is bigger number, right? Which is greater? That is the question, right? So obviously this is greater and therefore that becomes the wavelength of infrared. Is that clear to you? Correct? So that is how we could answer a word problem based on this situation. Now, here is practice exercise for you. I've actually told you most of the concepts you need to understand for doing anything on scientific notation, especially to understand the numbers written. Now, here is an exercise to convert the decimal numbers to scientific notations and the scientific notation numbers to the decimal numbers, correct? So that is what you need to do. I'll do one of them for you. Let's do the bigger one. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So we have to move here 1, 2, 3, 4, 5, 6, 7, 8, 9. I could write this as 1.2345678 9. 0 may or may not be written. 10 to the power of what? It is a big number, right? And you're moving left. So 9 places. Now it is at this particular point. You may or may not write 0. Secondly, we may be given the question saying round it to some significant figures. In that case, you may have to round it to some significant figures. For example, round it to 3 significant figures. You could write 1.23 into 10 raised to power 9 in that case. Perfect. So those are the questions which you could do. Now let's take one of these. Oh, this is just 10 to the power of 1, so the same number comes anyway. I marked it. So why not? So I'll just write this as 6.12. So when it is 10 to the power of 1, that means you're multiplying by 10, right? 61.2, not 6.12. So 10 to the power of 0 is 1. 10 to the power of 1 really means you have to multiply by 10, and so the answer will be 61.2. I hope that makes sense, right? So rest I'll leave for you to do. We do have 10 to the power of 0 also in this question. Now here is practice exercise question 2 for you. We are doing conversion to scientific notation. Complete the following table. The numbers are written on the left side. you need to write these numbers in scientific notation on the right side. Pause the video, copy these questions, answer, and then look into my suggestions. Now let me do one of them for you. 365 divided by 10,000. Let's see how to do it, right? So I'll adopt many different ways of doing this. One, we could think as writing 365 times 10 to the power of, how many zeros are there in the denominator? 4, but with negative sign. Since we are dividing by this number, correct. Now, we have to look into the decimal position. So, decimal should be written after 3 because the number should be between 1 and 10. So if I want to write this as 3.65, I'm moving the decimal two places to the left, that is to say add the exponent by 2. So when I do minus 4 plus 2, I get minus 2 as our answer. So that is one way of doing it. Is that clear to you? The other way is we could think about first rounding it, right? So we say, well, dividing by 100 is putting the decimal straight after the 3. So I could also write this as equal to 3.65 over 100. Since those two zeros will push the decimal towards the left side, make the number smaller, equivalent to 3.65. And we know now 3.65 times 10 to the power of minus 2, exactly the same answer which we got earlier. So however, any of these approaches can be adopted to write the scientific notation. So I hope this concept is clear to you. Perfect. Now let's take one example of multiplication. Now here is one which is so 0.00005 times 100,000. How do we do that? Well, you can straight away count decimal positions. Since we are multiplying, the number is becoming bigger. So in this case, we are moving the decimal to the right by 5 positions. So count 1, 2, 3, 4, 5. So it comes after 1, so the answer is 1. Now 1 is very interesting. You could write just 1, or you could also write 1 into 10 to the power of 0, because in scientific notation you have to write with a times 10 to the power of something. So 10 to the power of 0, 10 to the power of 0 is 1, 1 times 1 is 1. Well, in some cases we do allow you to write just 1 as a scientific notation for 1, right? Okay, let's move on and take another example. Now in this particular case, there are again 6 questions for you. I'd like you to pause the video, answer these questions, and then look into my suggestion. Well, the numbers here are million, billion, and thousands and nanometers, right? These are also the short forms of writing makes a lot of sense, correct? 7.8 billion is the world population, correct? So this is the world population, 7.8 billion. Now, if you have to write it in scientific notation, we know what billion is, right? So it has 9 zeros. So straight away you could write 7.8 into 10 raised to the power 9. That is how you could write it. 3000 means divided by 1000. 3 times 10 to the power of minus 3 could be your answer for this. Nanometer, do you remember nanometer? 10 to the power of minus 9. You're right. So you could do 10 to the power of minus 9 for nanometer. So that is how you're going to answer all these questions. Perfect. So I'll leave that for you and move on to the next question. Or should I do one of them? Let me do the first one for you, where we'll write 150.52 million kilometers. Okay, so let's write down. We have to write this to scientific notation, so we have to write 1.5052. And in doing so, what did I do? I moved the decimal 2 places to the left. Whenever you move to the left, your powers are positive, and it is 100. Correct. 150 makes sense. 100, right. That is how you're going to do it. Is that clear to you? Let's move on and take the next question, which is another practice test question for you. And this time you need to round your figures also. So we have the number 597.24 into 10 raised to the power 22. Now when we say round to 3 significant figures, in that case what do we mean? We mean that only write the first 3 numbers in scientific notation. So you may have to round it. Do you understand? So in every case, you have to only write the three numbers. So highlight those. These are your significant numbers in which you have to write the answer. Do you see such an easy way of showing it? So that is what is going to be your answer. And now the question is to round them and then write them in scientific notation. Perfect. Now these are very important numbers. Earth's mass, proton mass, millimeters to inches conversion, division. This is how we show the division of reciprocal and multiplication, right? We'll talk about this also. Anyway, so that is an exercise. Let me show you one of them. So for example, if I want to do this particular thing, which is 16.726, then, and we have to round it to three significant figures, it'll be 1.67, right, into 10 to the power of, since I moved it left, that means I have to add the power by 1. So it becomes minus 27. Minus 28 plus 1 is 27. That is how you're going to get it. And that is the mass of a proton. Okay, we had it in earlier questions also. So I hope now it is clear. Try to do this. Write down your answer in comments. I can always check them up. The last question for you here is, you need to write them in, this is all given about distance from sun. Okay, so the question here is, distance from the sun of some planets is given below. Arrange them in ascending order. Ascending means, as you understand, increasing order, right? So arrange them in increasing order. You can actually pause the video, write down your answers, and then get the solution. Now, as an exercise, what we will also do here is we'll also write them in scientific notation. So first write them in scientific notation. And then increase them, correct? So I've added this particular column. So basically, for example, the first one, you can write this as 1.496 into 10 to the power of, since we moved left, we have to add the power, correct? So 8. So likewise, you could actually write them all first in scientific notation, then compare. For example, for the Jupiter, it will be 7.785 into 10 to the power of, you moved this time two places, correct? So that becomes 10 to the power of 8. Do you see that? So once you write them in scientific notation, then what you have here is the power which can directly be compared. Is that clear to you? Correct? So that is your first part, and then do it. Otherwise, you might do a mistake. Okay. The last question for you to explore is, Neptune is 4.495 billion kilometers from the sun. The distance from the sun is so many billion kilometers. It is farther than all those other planets written. You know that. Find the ratio of the distance of Neptune and Earth from the sun. So that is what you have to now find. So distance from Neptune to Earth from sun. Okay. So once you write them in scientific notation, then actually you can straight away compare the degrees, right? The n, the order of this particular number. So I hope you have understood the concept. With that, we come to an end of this particular exercise. As you have seen in the last example, it is beneficial to write all those numbers in the form of scientific notation, since the value of n, which is the order of the magnitude, can help you answer all such questions. So I hope everything is clear to you. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.